the last lesson in this unit is over projectile motion, which is essentially when you throw an object in the air. You throw an object in the air and then it goes up and then it comes back down, assuming there's no wind or any outside forces like that. There's a scientific formula that actually can calculate these objects. And so we're going to look at the equations first and how the equations are always set up. So every question like this, so it's going to be like a word problem. It's going to be there's an object thrown in the air and da-da-da-da-da. So the first number, that's your A value, it's always negative 16. Anytime an object is thrown in the air, has negative 16. Your B value is the velocity. And the C value is the starting height. So if you were standing on a balcony and you threw it up, okay, you would have to incorporate that into your function. Now, if it doesn't give you a starting height or you don't see a number at the end, we assume that our starting height is 0, meaning it was thrown from the ground. And so what that looks like, we write the equation a little bit different. Instead of saying y equals, we use h of t. H meaning the height. So this function gives us the height of the object at some time. T is time. So if I was saying, okay, what is the height at 2 seconds? The height at 2 seconds, T is time, equals, it's negative 16 T squared plus VT, so the velocity, plus S for the starting height. And sometimes you'll actually have to come up with the equation yourself. You'll just have to look back and remember this pattern that it follows. It always has a negative 16, and then you fill in the velocity and you fill in the starting height. Now, there's always the same types of questions being asked. So I'm going to basically tell you how you would go about answering each question. And just a brief little thing here. If on a graph, your x-axis represents your number of seconds, so your time, while the y-axis represents your height. And so in general, most of your functions will look like this. So if you throw an object in the air, it goes up as time goes on and then it comes down. So if it says to find the height at some specific time, find the height at 2 seconds, find the height at 1.3 seconds, all you're doing is plugging in that time for t. So plug in the number for t. So if it gives you a specific time, plug in that number. You'll also be asked a lot about the maximum height. So like up here, this is the maximum height. That is the highest that it reaches. What is that point on this parabola? It's the maximum or the vertex, right? So the maximum height, this is the y value of the vertex. And we got this in lesson 5.3 is where we kind of got that. So you could look back at 5.3 for those formulas and stuff. Now, the amount of time that it takes to reach the maximum height. So that would be the x value of the vertex. So your maximum height is your vertex, and the time is on your x-axis. So it's the x value of the vertex. And we use formula negative b over 2a to get that. And this is also lesson 5.3. What about when it hits the ground? What are those points? So the height is 0, it hits the ground. What are those points on the graph? The X-intercepts. Oh no. X-intercepts. And just always use the quadratic formula for this. So if it asks for the amount of time or how long it takes to hit the ground, you will be using the quadratic formula. Sometimes you may get a negative number. And you will get a negative number on the examples where it has a different starting height. So if you get a negative number, you just ignore that one. You only write down the positive number because we don't have negative time. So the amount of time it takes to reach the ground, you only report the positive number. All right. So let's get into some examples. And you'll want to be referring back to this information. A soccer ball is kicked from the ground with an initial velocity of 90 feet per second. And then it stops there. It doesn't give us any other starting height. And this one actually gives us an equation. The equation, h of t equals, see, it starts with a negative 16 t squared plus, and then the 90, that is your velocity, 90t, and then it is basically plus 0 because it didn't start off higher off. It was from the ground. So it gives us that equation. Number 1 says, what is the height of the ball at 1.2 seconds? So this one asks for the height at a specific time. So look back to what we just wrote down to see how we are going to solve this one. We're actually going to plug in 1.2 for t. So h of 1.2 equals, so the height at 1.2 seconds equals negative 16 times 1.2 squared plus 90 times 1.2 equals. So I would recommend using the store button. So 1.2 store x, hit enter, and then type in negative 16x squared plus 90x. And you get 84.96 feet.
What they launch that thing with, Tan?
I guess. It says it was kicked. Maybe a robot.
Wait.
Number 2, how long, so that's talking about the time, does it take for the ball to reach its maximum height? So look back up here towards the top and see how we're going to solve this one. How long it takes to reach the maximum height. What are we actually finding? What? The x value. The time it takes to reach the maximum height is the x value of the vertex. So we're going to use the formula negative b over 2a. What is my b value? 90 over 2. And what's my a? Negative 16. Very good. So alpha y equals gets my fraction. Oops. And we really don't want to leave a fraction as our answer on this, because if I say it was 45 over 16 seconds, that doesn't make a lot of sense. So to convert it, the easiest way is just to type 45 divided by 16, and you'll get 2.81 seconds. What is the soccer ball's maximum height? So what is the maximum height? What am I finding? The y value of the vertex. So we have to plug in 2.81 from this problem up there. So when you find the x value, you plug that number back in to get the y value of the vertex. So we're going to do negative 16 times 2.81 squared plus 90 times 2.81. And you can type it in like this, or you can use the store button. And we get 126.56 feet. So that is the highest that the ball actually gets. And then number 4, how long does it take the ball to reach the ground? What are we finding for this one? Do what? Use a 0 for what? The height is 0. So we're setting the negative 16t squared plus 90t equal to 0. So look back at this part up here that we wrote down at the beginning. What am I going to need to use? The quadratic formula. So I'll write that formula down.
So is all these just like one big problem?
Yeah. So this is the quadratic formula. Looking at my problem, what is A? Nope.
No, A is negative 16.
A is the first number. So A is negative 16. B is 90. What is C?
2.1.
0. In your equation, you don't have a plus or minus any number yet. So your C is 0. And then fill in your A, B, and C to the formula. Remember what we did on this lesson? We just typed the whole thing in the calculator at once. So alpha y equals gets your fraction. And type it in. One time use a plus. The first number that you get is what? 0. And if we think about this object, it started on the ground. So when the time was 0, that's your starting point. So this one really doesn't count because it started on the ground. We want to know when it ends up on the ground. So we have to go back and get the one with the minus. So anytime you have a 0 or a negative number, don't use those. Just use the positive number. And we want to leave it as a decimal because when I say 45 over 8 seconds, that doesn't make sense to you. 5.6 seconds is a little bit better. So 5. Where I did use a negative. The B value is a positive 90. And so I use the negative here, and then this one doesn't have a negative with it. You just put your B value. So 5.63 seconds. And here's your hint, tidbit of information. The one, you'll always use the minus. There's really no need in typing it in twice because the plus sign on the plus or minus, the plus sign is always the one that gives you either 0 or the negative number. So you really only need to type in the minus. Yep. The only questions you'll see are like that. All right, here is our next scenario. An apple is launched directly upward at 64 feet per second. That means that is your velocity. When you see feet per second, it's talking about your velocity. From a platform 80 feet high. So this is your starting height. And I'm going to rewrite what we had on the front so you don't have to keep turning. So the height at whatever time is negative 16t squared plus velocity t plus starting height. So what we're doing is subbing in for these two parts. We have a velocity and we have a starting height. And we're just filling in for those. So you have to look at your problem. You have to read your problem to get those two numbers to fill in. Your velocity will always go before the t, and your starting height will always go at the end. Are there any questions on that? And there's always a negative 16 in the front. That's the science behind it that I don't know anything about.
So this isn't quite like the first page.
Well, the first page, it just gave us the equation to start in the problem. This one asks us to write the equation ourselves. Most of them will ask you to write the equation.
We don't plug anything for
Not-
extra t?
Not yet. We may, like on question 7, we will. But this one, the first question, the questions are a little in a different spot. So number 6 starts out, how long does it take for the apple to reach its maximum height? How long does it take? So the time that it takes to reach its maximum height. So if I look back over here, the time it takes to reach the maximum height is the x value of the vertex. So negative b over 2a. What is my b value? 64. What's my a? Negative 16. Your a value is the first number. It will always be negative 16 on these problems.
Now, when you put it in the calculator, is it a negative or is it just a minus?
If it's in the very front, it has to be a negative. And if you try to put a minus, it'll give you that error that you did it wrong. And what do we get? 2 seconds. Then it says, well, what is the maximum height? So we know that we hit the peak at 2 seconds. Well, what is that height? We're going to plug in 2. Because we got 2 in that other part. We're plugging in 2. Because we know that's when we're at the maximum height. And you should get 144 feet. Questions?
I did something wrong. Because I got 244. Oh, I put 2.
But that's right. You put 180 there instead of just 80 at the end. Right. Number 7. What is the apple's height at 0.7 seconds? So what do I do on this one? Plug in 0.7.
So that's what confuses me, because you go from one problem with something else in a T spot, and then you go to another problem, you have something else in a T spot.
Well, the T is that represents your time. So I'm finding a height at that specific time. So yeah, your time is going to change. That's why I gave you that stuff at the beginning, so you know what to do where. Like this one, I put a 2 in because I wanted to know the maximum height happened at 2 seconds. So that's why I plugged in a 2, because I wanted to know where it was at 2 seconds. This one, I want to know where it's at 0.7 seconds. And it is only at 116.96 feet. Number 8. How long does it take the apple to reach the ground? So what am I doing here? Quadratic formula. So when it says how long does it take to reach the ground, it's referring to your X-intercepts, which we will find with the quadratic formula. And I'll rewrite it so you don't have to flip back and forth. Remember the thing that I told you? Just use the minus on these problems. Because if you use the plus, that's when you're going to get either 0 or a negative number. So just a minus is okay on these problems. That'll save you some time.
What's our A and our B?
So our A is -16, B is 64, C is 80.
Okay, so one more time.
So back up here at your problem, the first number is always your A, the second number is your B, and then your last number is your C. Yep. And you should get 5.
So you need to do subtraction instead of addition.
Yeah. Because if I do addition on this one, I'm going to get -1. So anytime you use addition on these problems, just because of the way they always work out, the addition option is always going to give you either the negative or the 0, which I said you don't include as part of your answer because we don't have negative time. I only care about when it stops and hits the ground. You get 5 seconds. We are actually going to stop there for today.